Good morning students, welcome to class 8 mathematics. In the previous class we studied chapter 2 exponents. In that chapter we studied about powers and integral exponents of rational numbers. In this chapter 3, squares and square roots, we are going to study about the squares of integers, rational numbers and decimals. Also square root of perfect squares by prime factorization and long division methods. These things we are going to study in this chapter. So what is perfect square? The squares of the numbers are called perfect squares. The square of some numbers are called perfect squares. Example, 4 is a perfect square of 2. 9 is a perfect square of 3. 16 is a perfect square of 4, and so on and so on. In this way, here 4, 9, 16 are perfect squares number. Perfect squares. So there are some properties by which we can know about the perfect squares. I'm going to discuss some properties of perfect squares. Properties of perfect squares. First property, we know that the numbers that ends in 0, 1, 4, 5, 6 or 9 only are perfect squares. It is not necessary that the number ending with these numbers will be a perfect square. It is not necessary that numbers ending with these numbers are perfect square. But it is sure that a perfect square ends with any one of the above digit. Example, 4 is a perfect square. 16 is a perfect square. 9 perfect square. 100 is perfect square ending with 0. 36 is perfect square ending with 6. 49 is perfect square ending with 9, and so on. But there is other number also ending with 4, like 14 ending with 4, 26, 29, 10, and so on and so on, are not a perfect square. Now one thing, now the number ending with 2, 3, 7 or 9 or 8 will not be a perfect square. Will not be a perfect square. Next, I will say that example, number ending with like this 12, 22 or 23 or 33 or 43, whatever, 27, 17, 37, 47, like that, 18, 28, 38, 48, etc. are not perfect square. Now property 2. Second property says that the square of a negative number is always be positive. Therefore, a perfect square is always positive. Here, example, we can see that negative number, say minus 2. Square of minus 2 will be minus 2 into minus 2, and that is minus into minus is plus, 2 into 2 is 4. So the square of the negative number will be positive. Another, we can give the examples in the same way, like minus 7. Square of minus 7 is minus 7 into minus 7, and that is equals to minus into minus plus, and 7 7s are 49. You know that we get 49. And if we take the square of positive number, it will be positive. And 7 square will be 7 into 7, 49. This shows that perfect square is always positive. Hence, perfect square is always positive. It can never be negative. Now, third property, the square of an even number is even, and that of odd number is odd. It means square of an even number is even and that of odd number is odd. So let's see an example to explain the property, the square of an even number is even and that of an odd number is odd. Suppose let the number, even number, be 4. The square of 4 will be 4 into 4, that is 16, is an even number. Even number. 6 square, which is an even number, is 6 into 6, that is 36, is an even number. 8 square is 8 into 8, 64, is an even number. Similarly, odd numbers. Let's see odd numbers. 3 square is 3 into 3 is 9, is an odd number, is an odd number. Another, let it be 5 square, 5 into 5, that is 25, is an odd number. So by this we come to know that square of even number is also even, and square of odd number is also an odd number. This is the third property. Next property I am going to do in the next page. Property 4. The number of zeros at the end of a perfect square is always even, that is in pair. That is in pair. Square of zeros at the end of perfect square is always in pair, that is even. Example, square of 10. 10 square is 10 into 10, that is 100. We see here zeros are even, that is in pair, that is in pair. Now 20 square, 20 into 20 is 400. Here also we see that 0 are in pair. Now come to that is 1000. Now come to the example, another example, 1000 square. 1000 square means 1000 into 1000. We see 1 0 0 0 0 0 0. That is, we see here zeros are in pair. Here 2 2 and 2, these are in pair. So here also we see zeros are in pair. So this is the perfect square having 0 in pairs, that is in even numbers. Next property, property 5, it says that for any two consecutive, means continuous, one after the other, consecutive natural number n and say n and n plus 1, let it be, we have n plus 1 square minus n square is equals to n plus 1 plus n into n plus 1 minus n, and that is equals to n plus 1 plus n. Here we see that using the identity a square minus b square, we get a minus b into a plus b. The same thing is applied here. So n plus 1 square minus n square, we get n plus 1 plus n. This is the identity. Means if we find the difference of the two consecutive square numbers, we will get n plus 1 plus n. Suppose we have two consecutive number 4 and 3. These are the consecutive numbers. Now square, 4 square minus 3 square will be 4 plus 1 plus. So suppose we have two consecutive numbers 4 and 3. So we get 4 square minus 3 square. The difference of the difference of the two consecutive squares, we get 4 plus 3 equals to 7 according to this identity. Another example we can do is, let it be 15 square minus 14 square. The square of the two consecutive numbers. The difference we'll get is 15 plus 14, and that is equals to 29. This is the answer. Next, another example I can explain is, let it be 19 square minus 18 square. So by using identity, a square minus b square is equals to a minus b into a plus b. We get 19 minus 18 into 19 plus 18. That is 1 into 19 plus 18. That is 19 plus 18. That is equals to 8 plus 9, 17, and 3, 37. In this way, we can directly do, without going through all these steps, we can directly go to these steps. That is 19 square minus 18 square equals to 19 plus 18, as we have done here. 15 square minus 14 square is equals to, directly we have added 15 plus 14 gives 29. In the same way, 19 square minus 18 square can be directly added like this. 19 plus 18 to get 37. This is the answer. This is the fifth property. The rest property I am going to do in the next video.